Okay, so here's a really scary looking molecule, at least presumably it scares you guys a little bit. There is a lot going on here. There's a lot of oxygen, there's a lot of nitrogen. All right, so we're going to talk about how to break this down just one heteroatom at a time and identify functional groups. All right, so here we have an OH group. It's bound to a carbon. That carbon does not have a carbonyl, so this is an alcohol. All right, there's lots of alcohols in this molecule. All of these are alcohols. Let's see if I can get them all in the first go here. That's an aromatic alcohol, the last one I just highlighted. And I think that just about does it. Okay. These are not acids because the oxygen of the OH group is not directly attached to a carbonyl carbon. All right. Some of them are close to carbonyls, but they are not directly attached to carbonyl carbons. Okay. So this carbon right there is not a carbonyl carbon. It's close to another carbonyl carbon, but it's not directly attached. Okay. Here's another one. This is close to a carbonyl, but the carbon itself is not a carbonyl carbon. You have to go one more carbon, two more carbons over to get to a carbonyl. So this OH group is an alcohol that just happens to be close to a carbonyl. It's still an alcohol. Okay. Oh, I missed one. There it is. There's an alcohol. Okay. So let's switch colors here. So here we have an oxygen. I didn't actually talk about these in the slides, but this is in your book. So here we have oxygens that are attached to carbons on both sides. Okay? Neither of those carbons contain carbonyls. Okay, so this is an ether. All right? And this is an ether. Right? There is a technical term for this, which is a ketal or acetal. We'll talk more about that towards the end of the semester. So as far as you're concerned right now, we're going to call those ethers. All right, but what I'm mostly concerned about is you guys knowing the difference between acids and alcohols and amides and amines. All right, so I'm going to switch colors one more time. All right, so here we have a nitrogen. Okay. This nitrogen is directly attached to a carbonyl. All right, this is an amide. Here we have another nitrogen. It's attached directly to a carbonyl. That is an amide. It is not an amine attached to a carbonyl. It is an amide. It is a different structure. Okay, here we have a nitrogen directly attached to a carbonyl. That is an amide. Here we have a nitrogen attached to a carbonyl. That is an amide. Again, amide here, nitrogen attached to a carbonyl, amide, again. So there's a ton of amides on this molecule. All right, but finally, we find a nitrogen down here. This nitrogen is not attached to a carbonyl carbon. All right, it's not directly attached to a carbonyl carbon. This is an amine. Okay, the reactivity of amines and amides are drastically different. All right, and so it's very important to be able to differentiate the two from one another. Okay, so again, it's kind of like the example that we went over in class with chirality. When you're identifying functional groups, just find one heteroatom and evaluate what it's directly attached to. Okay, don't worry about the rest of the molecule. Just break it down piece by piece. All right, and I know it's easier said than done when you're first getting started. But take a look at this again. If you're confused, use your book. I don't mind if you use the book on your take-home quiz. The whole point is to get you guys used to recognizing functional groups in complex molecules, because I won't be surprised if they do ask you something like that on an MCAT with a scary-looking molecule. All right, so as usual, if you have any questions, feel free to email me or stop by office hours, and we'll talk about it. Thanks.